Good afternoon, class, and welcome to this moment's class. We have just had a class on MGF, moment generating function of a Poisson random variable x. And now we want to continue at looking on the characteristics function of the moment of the Poisson random variable x. Characteristics function. We want to look at the characteristics function. Characteristics there, function. Of for a Poisson random variable. Poisson random. Permit me to write R dot V as a random variable. Poisson random variable. We first of all begin by giving the formula for the characteristics function of any random variable x. It is given as of x of t equals e of I t x. This is how it is given. Permit me to divide this my board. Okay? Now, this our e of eitx is expressed as we have this of x of t equals sum over the range of what x of e of it what x p of x equals x. I repeat, the formula for the characteristics function of any random variable x is given as this. But when we have additional information that this random variable x follows a discrete random variable, this characteristics function will be expressed this way, making use of sum over the range of x and making use of what of the PMF, probability mass function. Okay? But we are discussing a Poisson random variable, so we need to recall for ourselves the PMF of a Poisson random variable. So we now say but for a Poisson random variable, for a Poisson random what variable, P of capital X equals small x is given as lambda raised to power x exponential minus lambda all over x factorial. So for us to be specifically now talking about the characteristics function of a Poisson random variable, we are now going to write, therefore, what I have becomes of x of t is now given as sum over the range of x of e of I t x multiplied by, I won't write this, I will write this one. And of course, you know that the range of x is what? 0, 1, 2, down to positive infinity. So I have lambda raised to power x exponential minus lambda all over what? X factorial. Okay? Now, if you watch now, this our lambda exponential minus lambda is a constant. It doesn't contain s. So we bring it outside the what? The sum. So it becomes what? Exponential minus lambda sum over the range of x. We have e of it what? X multiplied by lambda raised to power x all over x factorial. I can write this thing to be this way, that is equals to lambda exponential minus lambda. Then I have sum over the range of x of what? Lambda of e of it all raised to power what? X. All over what? X factorial. Reason being that this contains x and this contains x. So what I have left here is exponential it, which is exponential it. Here is my lambda, here is my lambda. If I want to return back here, lambda raised to power 2 raised to power x will give me lambda raised to power x. Exponential it multiplied by this it multiplied by this x gives me what I have here. This is my x factorial, this is my x factorial. So this thing becomes exponential minus what? Lambda, I open a bracket. We are discussing Poisson that begins from 0. So this x begins from what? 0. When x is now 0, what I'm going to have here becomes what? 1. Because anything raised to power 0 divided by 0 factorial will going to give me 1 plus. When it becomes 1, I will now have the whole of this thing, which is what? Lambda E of I of t. Because 1 factorial is 1, which divides this thing to be that, plus. I have lambda E of I of t all raised to power what? 2 all over 2 factorial plus. I have lambda of E of I of t all raised to power 3 all over 3 factorial plus down to infinity. What I did here is when x is 0, we evaluate this thing to be 1. When x becomes 1, 1 goes here, 1 goes here. We evaluate this thing to be this. When x becomes 2, 2 goes in here and 2 goes in here. We evaluate this thing to be this. When x becomes 3, 3 goes in here and 3 goes in here. We evaluate this thing to be this thing. The evaluation continues till positive infinity. Okay? So what are we going to do? There is a series which we call the Maclaurin series that says that whenever we have this kind of expression, 1 plus this, that the whole of this in the brackets can be given as exponential lambda EIT. That everything in this bracket can be expressed like this. Okay? So in that case, I'm going to say that this equals, of course, we had exponential minus lambda here earlier. So I have exponential minus lambda multiplied by this exponential what? Lambda EIT. I have exponential lambda here, I have exponential lambda here, so I can factor. So if I factor, what I'm going to have becomes what? Exponential what? Lambda, open a bracket. What will be remaining here is what? EIT. Then minus. What will be remaining here is what? Is 1. We close it. So this is the characteristics function of a Poisson random variable x. As a word of recap, the formula for the characteristics function of any random variable x. We go ahead. When we have information that this random variable x is discrete, the expression becomes like this. Okay? But the PMF of a Poisson distribution which we are discussing is given as this. So replacing this PMF with the PMF of that of Poisson distribution, we are discussing squarely the characteristics function of a Poisson distribution, which becomes as this. Bringing this exponential minus lambda outside as a constant, and then we have this left. Trying to make the equation more compact or the more, I decided to express this way, which of course can easily return back to here. I'm trying to evaluate this quantity when x equals to 0, x equals to 1, x equals to 2, x equals to 3, down to infinity. I have this. And according to Maclaurin series, when you have this, it can be expressed as this. So when I return back, I had this one here, which is this, multiplying by that, factoring it now to be this way. So this becomes a characteristic function of the Poisson random variable x. So anywhere you see this, it is the characteristic function of a Poisson random variable. In our next class, we are going to discuss the Poisson approximation to binomial distribution, including the proof of the formula and solving of the problems on it. Do not forget to subscribe to our YouTube videos. Seriously, we are committed to making a change to your understanding and concepts about this subject, matter, statistics, and mathematics. Stay tuned.